So how should you have the solution for the polynomial inequalities? And basically polynomial inequalities actually resulted into having two or more real values, and these values are said to be the critical numbers. So let us see that we should have to go over and have the solution for the polynomial inequalities, if that's the case. Now let's say we have a problem, let's say given us x squared, and let's say plus x minus 6 less than 0. Now it should be a positive 6 on the other side. It should have been this way. Should be less than, that should be a 6 there. Now how should you be able to have the solution of this problem? So you should have to treat inequality symbol the way you treat equal sign, in the sense that we have to bring this 6 towards this direction, towards that side rather. So have it as x squared, and plus x minus 6 is less than 0. So that's the first thing to. Now the expression you have it here, how should you be able to solve for x in that way? So the factor method can work. So in that case we'll have it as x squared, and what are the factors of negative 6? When you add will give us actually a positive x, that is positive 1. So have it as a 3x minus 2x and minus 6 less than 0. So now which means we'll have x into x plus 3, like that, negative 2 into x plus 3. So less than 0. Make sure that you understand about solving quadratic equations. So because that are going to apply in this lesson, as you can see. So now we'll have it as x plus 3 and x minus 2 and less than 0. So what are the critical values here? We'll have x is equal to negative 3 and x is equal to 2. So these are the critical values. But now we should have to bring these critical values on the actually number line, and I should have to generate the intervals from the critical values. So that's how we should have to solve the polynomial inequalities. So we have the critical values that are given us. Now we should have to come up with the number line, and that will help us to come up with the intervals from the critical values in the number line. We have this is the negative infinity, and this is the positive infinity. We have this one as the negative 3. They have this one as 2. I understand you know what is the number line in some sort of inequality context, actually a concept. So should have that. So now we'll have these intervals. We have this interval, this interval, this interval, and since the inequality symbol is given as less than, it means the brackets has to be the open brackets. So take note of that. So now we have the intervals that are given as negative infinity, comma negative 3, and we have negative 3, comma 2, and we have 2, comma positive infinity. These are the intervals. Then which interval is the solution for our problem? So we should have to go. We should have to operate what you call the testing table. We should have to come up with a testing table to test which interval is the best solution for this case. So now the testing table looks like this. We'll have interval, and we'll have the testing number, which is the testing value, and here we'll have the function that we are having, the one which is equal to 0. Now have it as x squared, or else since the function was factorized, it means we'll have to present the factorized we'll have to present the factorized cases and for the equation. Since we had it as x squared and plus x minus 6, so in this case we should have it as x plus 3 and x minus 2. We should have to present this case. instead of having this one. Of course this is also okay, but this is more simple to have it up to. That's now, which means we'll have, should be now x plus 3, and that should be x minus 2, and here we'll have the conclusion, so it should be that. So the interval testing number, the function in the conclusion here, we'll have that one out. So what is the first interval? Now the first interval is given as negative infinity to negative 3. So what is the test number within this interval? Let's think of having it as negative 4. So that's the value that's the smallest value or the active number within this interval. So now we'll have to substitute negative 2, negative 4 into this. So now which means we'll have here as the negative, we'll have negative 4 plus 3, that will give us negative 1. And here negative 4, we'll have it as negative 2. So which means we'll have negative 1 times negative 2, that will be given as the positive actually 2. So we'll have it as a positive 2. So since the number is positive, it means we'll have here as the positive. That's the conclusion. We'll have it as a positive. We may think of having it being written as a positive. So have it as a positive. And what's the next interval? We'll have it as negative 3, 2. So what's the testing number within that one? Simple, just have to get 0. So have 0 here, have 0 here. We'll have it as negative 6. So have negative 6. Since the number is negative, it means we'll have here as the negative. Then we'll have the final interval, which is given as should be 2, positive infinity. Let's think of having 3 as the testing value. So now we'll have here should be a positive 6, and here we'll have it as a positive 1. So which means we'll have a positive 6. Since the number is positive, it means the conclusion is given as the positive. So now, back to our actually inequality. We had it as x squared plus x minus 6 less than 0. Since the inequality favors the left hand side, it means our solution, actually our interval, which is the solution, is the one with the negative conclusion. So hence this equation or the inequality is being satisfied by the solution set in this actually interval. So which means the solution is given as negative 3 should be a 2. So that's the solution. So now what if we have this case? And say if we have also this kind of a case. Now it should be given as, let's say, 9x, that should be minus x squared, and that should be less than or equal to 20. So now try as much as possible to have 0 this side. We'll have to transfer 20 to the other side. And also now have it as negative x squared plus 9x minus 20 less than or equal to 0. So let's think of having the critical numbers there. So we'll think of the factors of, now have a positive 20 because negative 1 times negative 20. We'll think of, if we can use the a factor method to work. In the basically factor method, that's the only hope in this case. So now which means we'll have it as negative x squared. Now we should have it as a 5x plus 4x minus 20. And less than or equal to 0. Mind you should have to familiarize yourself on how to be able to solve the quadratic equations using the factor method. So now have it as now x, negative x, and should be that of plus 5. And now have it as a plus. I should have 4. So I should have it in this case. So let me just have to pair up these things. So which means I have this as that and also this one as that. So now I have to factorize this one and also this one as well. So what's that? So now which means I have now should be negative x, of which you have x, and that minus 5 should be that. And I'll have a positive 4 in the x, that should be minus 5. Less than or equal to 0. So now which means I'll have it as x minus 5, and like that, negative x plus 4, less than or equal to 0. So now what are the critical values? We'll have x as 5, and the x being given as, that should be negative 4, should be a positive 4. That is upon having solved this one. So you can have it as that. Then you have to present those values in the number, actually number line, and that you have the set of the actually intervals there. And of course you should have to keep this, that we can have to use when we'll be actually substituting the testing number. So we'll have the number line that will go like this. So this is the positive infinity, this is the negative infinity. And let's say this is 4, and that should be this is 5. So now which means according to our actually inquiry symbol, it means we'll have this as the brackets. So that can be given as that, and as that, there will be a cross brackets as that and also as that. So in this case, let me just have to present the testing table, and much as we understand what is happening. So now this is for intervals, so should be that, and this is the for the testing number, and I'll have x minus 5 and negative x plus 4 as that, and it should be now conclusion. And of course some books they separate these two in their own respective columns, but principle means the same. So now what's the actually a first interval? We have negative infinity, comma 4. So should be that. What's the typical testing number? I'll have it as a 5. Now should have it as, let's say 0. That's the very simple number to work out on. So I'll have here as the negative 5, and have here as a positive 4. That will be given as a negative 20. So since the number is negative, it means this is the actually a negative conclusion. So have the negative conclusion. And what's the next interval? Have a 4, comma 5 in those brackets. So what's the typical actual testing number you have to think about? Since the values are so close, you have to understand this thing. You have 4 plus 5 over 2. That will be given as the 9 over 2. Now which is about, now have it as 9 over 2. So that's the testing number. Now let's think of having 9 over 2 here. Let's have to see what will be the result. So now have 9 over 2 minus 5 should be that, the 2 minus that side will have 10 here, 9 will have it as negative 1 over 2. And of course, how about here? 9 over 2 and that plus 4. That will be given as 2 plus. Now have it as 8. So we'll have it as 8. This will have it as a 9. So which means we'll have 17. And that should be that over 2. So now which means we'll have, if I'm right in my calculations, but that's the way to go. So I'll have 17 over 2, and that should be that, and minus, and that should be times, not minus, but should be times negative 1 over 2. That is the same as negative 1, should be negative 17 and over 4. So have negative 17. So have negative 17 over 4. Since the number is negative, it means I'll have the negative conclusion here. So take note of that. Then now we'll have the final interval, and which is being given as this now. So that's what you have to understand about the solving of the polynomial actually inequalities. So now have a 5, positive infinity. So what's the typical testing number? So have it as, 5 is also part of the interval. By the way, I don't know what happened here, because a 4 as well as 5 are the part of the intervals. We could have just choose them. Anyways, but that could be also the way to go. A 4 as well as the 5 are part of the intervals you could have actually choose. But anyway, in this case, let's have 5. In this case, we'll have here 5, we'll have it as 0. And here, also have it as. And of course, if we think of having these values, then we want to get it, because these values are the real solutions and for our actually equation. Hence, we should not have to use those actually the values here, but we should have to use the values between. So this was the great idea, because if you substitute 5 here, we'll have it as 0, which is actually contrary from the expectations. So now we just have to choose the values between the intervals. So we are in line pretty fine. So this is the 6. Now if we have 6 here, we'll have it as a positive 1, and we'll have negative, and that should be that of negative, what is that? We'll have a negative 2. So 1 times negative 2, we'll have it as a negative 2. So since the number is negative, it means we'll have it as the negative conclusion. So now, looking at the inequality symbol that we have, less than or equal to, it favors. Now, this inequality symbol favors actually a negative direction, and hence we'll only have to choose the intervals that are giving us actually a negative conclusions. Hence, we'll have the whole of these actually intervals being the solution. So now we'll have it as a negative infinity, 4 should be that union, should be 4, 5, and union the other one. So take note of that. And sometimes we may have what they call the polynomial function with that is in a quotient form. Let's say we have this case, we have 2 minus x over, let's say 3 minus 2x, and should be greater than or equal to 0. So what is the solution for this case? So now as it stands here, we cannot actually cross multiply, because we don't know what is on the denominator, because it's either that this is a positive or this is the negative. And that is, if it is a positive, it means this sign can't be changed to be likewise upon having cross multiplication. But if it is negative, it means this sign has to change. But we're not so sure whether the denominator is positive or negative. So hence care has to be critically considered. So have to solve the numerator separately as well as the denominator separately, in the sense that we'll have the critical values being given as x is equal, now should be 2. And that should be a 2. And for the denominator, we'll have the critical values being given as x is given as now a 2 over 3. So now these are the critical values you have to understand. Then I should have to bring them on the number line, and as we are actually doing it. Yes, now which means we'll have it as a negative infinity, and this is the positive infinity. So now this is 2 over 3, and this is 2. But the care has to be considered. 2 over 3 shouldn't be part of the interval, because if you substitute it here, we'll have it as 0, which is undefined. So should have to know that one. So which means we'll have it in this case, also in this case. Only that this one will be part of the interval, that is 2. So we'll have that and as that. So those are the intervals. Now you should have to bring them on the testing. Now you should have to bring them on the testing after table. That you have now have the interval, the testing number, that is, and we'll have now 2 minus x over 3 minus 2x, and that one, and we'll have here as the conclusion. So what's the first interval? Have it as negative infinity to 2 over 3. So what's the testing number in that order? So we'll have, let's say it should be, so we'll have a testing number being given as, let's say, 0. So 0 is within the interval. So if we have 0 here, we'll have now 2 over 3. So now we'll have it as a 2 over 3. Since the number is positive, it means it is the positive conclusion. And I'll have 2 over 3 and a comma 2. So 2 over 3 is not part of the, actually is not part of the interval. So have that, but 2, it is a part of the intervals. So have to use this bracket. That is given as that. So what is the testing number within this interval? So have a 1. So have 1 here, have 2, and we'll have here 2 over 1. That will be given as 2. Now it should be, we'll have here given as 1, and over we'll have here being given as, let's say, 1 as well. So which means we'll have the value which is given as now 1. Since it is positive, it means the conclusion is given as the positive. And finally, we'll have a positive 2 to positive infinity. So what's the typical testing number? So we'll have, let's say, should be 3. So have negative 1 over, and we'll have negative 3. It should be negative 3, because we'll have here being given as a positive 6, and 3 minus 6 is given as negative 3. So we'll have it as 1 over 3. So that is the positive. So hence we'll have the positive conclusion. Now if that's the case, then it means we'll have to, now looking at the inequality symbol that we have, which is given as the greater than or equal to, so which means it is to favor the positive direction. So those intervals with the positives, it means will be the solutions. And for this case, we'll have this as the solution, this one as well as this one as the solution. Unless otherwise, if I had the poor calculations part, that is the way to go. So try to verify if all calculations were found bad. You should have to understand that one in that way. What if we have this case? Let's say we have it as, that should be x squared minus x minus 2, and say divide by, and that should be x squared minus 3x and plus 2, the which is greater than 0. So you can see that this is the quotient form of the polynomial function. So which means we have to solve for this one separately to have the critical values. So what is that? So now have x squared minus x minus 2, and that which is equal to 0. Now you should have to solve for x in this way. A factor method will have to work in the such that we'll have x squared and plus 2x minus x minus 2, which is equal to 0. And such that we'll have x and x plus 2, and have negative 1x plus 2, which is equal to 0. So which means the critical values will have x plus 2 upon having x plus 2 and x minus 1 is equal to 0. So now the critical values will be given as x is equal to negative 2 and x is equal to 1. So that is for the actual denominator. Should be rather for the numerator. So have those as the critical values in that order. Then we'll have them as this: x minus 2 is equal to minus 2, and x is equal to 1. Now let's go for the denominator. I wish to have the critical values there as well in the same case. So which means we'll have x squared minus 3x plus 2, that which is equal to 0. And of which we'll have it as x squared minus x and minus 2x. Should be minus 2x and plus 2, which is equal to 0. And such that we'll have it as x and x minus 1. That should be actually negative 2, and that should be that of x minus 1, which is equal to 0. So which means we'll have x minus 1 times x minus 2, that which is equal to 0. Now the critical values will be given as x is equal to 1 and x is equal to 2. So which is fine. So which means we'll have that and as that. So we'll just have only to pick this one, since the positive one we already have, so it is fine. So which means we'll have x being given as the negative 2. It should be a positive 2 rather, should be a positive 2. So it should be the positive 2. So take note of that. Then you should have to also go the same steps. You should have to bring those three values on the number line and generate the intervals, then do the need if there. So take note of that. But anyway, let me just have to highlight a little bit for you as well. Of course, you proceed that on your own. So positive infinity, this is the negative infinity, and of which you have, let's say this is negative 2, this is 1, this is 2. And those values from the denominator going to be part of the interval, in the sense that a 1 will not be part of the interval. So have it as that. Should be that. And even a positive 2 won't be part of the interval as well. So have that and as that. And while negative 2 will be part of the interval. So have them as that. So try to have the intervals from that on, and should have to go for the testing table and some stuffs using the same principles which we are talking about here. And now at your own time, try to have the following problems and appreciate the beauty of all these things. Let's say we have x plus 1 over should be x plus 2, which is greater than x minus 3 over this should be x plus 4. So how should we be able to have the solution for this problem? And of course we'll have to transfer this one to go to the other side, and that will be given as x plus 1 over x plus 2 and minus x minus 3 over x plus 4, which is greater than 0. Now express this one as the single fraction, and so that you should have the expression in a quotient form the way you have discussed it before. Now you'll be able to have that one okay. So try that one at your own time. And also try to have this problem out. Let's say you have 2x and over x plus 5 and plus x minus 1 over that should be x minus 5. Let's say less than 1 over 5. And also try that one as well. Of course you have to transfer this onto this side. Then I express the combination as the one fraction, as the single fraction, and you have your case in a quotient manner. Then you do the need if the way you have discussed it before. You also think about this one. So let's say have x squared, and that should be plus 3x. That is divided by x squared plus should be 8x plus 15, and that less than 0. And also try that one out at your own time. And what if we have this case? Let's say we have should be x squared minus x minus 1 over, let's say, x squared plus x, and that should be minus 1, and that greater than 0. And also try that one as well to have the solution. And think about this one as well. Let's say we have a 2x cubed and plus 5x squared and minus 7x and over should be 3x squared plus 7x and plus 4. That is greater than 0. And also try that one at your own time. And what if we have this case as well, and try to also appreciate it. And we should have, let's say, this case, the 4x squared minus, and that should be 9, and the minus x squared minus 9, the part 2, and we have it as greater than negative 5. So what is the solution of that one? Also try that one out. And let's say have x squared and 3x squared, and this should be plus 11, and which is greater than or equal to 4. And also try that one as well. So that's how you should have to understand the way you should have to solve the polynomial inequalities. So thank you.